Okay, so today we're going to start chapter 10. We're going to just introduce you to lesson 1, which is parabolas. Chapter 10 is going to be the chapter on conics. We are going to be covering circles, ellipses, parabolas, hyperbolas, all these different conic shapes. So the first one today is the parabola. And by definition, a parabola is the set of points in a plane equidistant from a fixed point and a fixed line. And this is what's new to us in chapter 10. This fixed point is going to be called the focus. And we're going to be calculating this focus point for all of our parabolas. We're also going to be finding a fixed line, and that fixed line is going to be an equation, and it's called the directrix. Now, back in chapter 3, we did graph parabolas, and they look like the one that's here in figure 6, this U shape. Notice the focus point here is inside our parabola. And then the directrix is going to be is a line that's on the back side of that parabola. Now, we also graphed in chapter 3 the upside down U. So when our A value is negative. We're also going to be graphing in chapter 10 parabolas or sideways parabolas that are going to look like the letter C or a backwards letter C. Notice all of our focus points here are inside that U shape or that C shape. The directrix is on the back side. And we're going to learn how to calculate all of these. By that, if we go back to the previous picture, let's say this is at the order pair 0, 2. Notice if I put a little line here, we can see that it's 2 spaces away from the vertex. And then this directrix line, we could say that this is at the line y equals -2. Notice both are 2 spaces away from the vertex. And that would have been my p-value. So the p-value is going to be the distance that the focus point is away from the vertex and that the directrix line is away from the vertex. And we're going to see how to calculate these coming. So back in chapter 3, our equation for parabolas looked like this. Y equals x squared. And remember, we had the parent function. The vertex was at 0, 0. And then from there, we did different shifts on it. Remember, if we did y equals x squared plus 3, that meant I took my graph and I shifted it 3 units up. Or if it had a number in front, remember it got skinnier because it went up faster. Or if it was a smaller number, it got wider. So these were the different things we saw in chapter 3. Now what's going to happen to us is we're going to have a different form of the equation. And our equation is going to look like this. So when our variable that's squared is the x term, our graph is still going to look like the original form. It's x squared. So this one also has x squared. And the form is going to be x squared equals 4py. When the variable that's squared is the y, then this is when our graph will be the sideways parabola, and it'll look like a C or backwards C. Now, when the number, the 4px, is positive, then it'll look like a C. But when it's a negative number, it'll be backwards. Just like the same with our U and our upside down U. Remember, when it was positive, it was happy, and when it was negative, it was sad, and it looked like a frown. So the p-value that we're going to be calculating is going to be the distance from the vertex to the focus point and the directrix. So this point, this focus point and this line, they're both going to be the same spaces away from the vertex. And what I mean, so here is my first example. The first few examples that I do, all of the vertexes or the vertices are going to all be at 0, 0 because they're all taking on this form. X squared equals 4py. Now, this 4p that's right here is really represented by a single number that's in front of the variable that's not squared. So you see how in this given equation, the variable that's squared is the x. The variable that is not squared is the y. And whatever number is in front of the variable that's not squared is your 4p. So I need to figure out what the value of p is, so I'm going to make an equation. I'm going to set 4p equal to 8. I'm going to divide by 4, and I find out that my p-value is 2. So when I go to graph my focus point, I know it's going to be 2 units away from my vertex. And the same for my directrix line. Now, before I put in my focus point and my directrix line, I'm going to graph my parabola. So I'm going to go ahead. I already know that the vertex is at 0, 0. I am now going to come up with another order pair that is going to be on the parabola. So I can pick whatever x value I want to plug in to this equation to get another ordered pair. So my equation is x squared equals 8y. I can pick whatever I want. I'm going to try to pick the easiest number. I'm going to try to plug in a 1. So I'm going to say I'm going to let x equals 1 so I can get a y value so I have an ordered pair to graph. So 1 squared equals 8y. 1 equals 8y. Divide by 8. And y equals 1/8. So the order pair I can graph to start making my parabola shape is going to be 1, 1/8. I'm going to go over here. I'm going to graph it. Now I know it's kind of hard to get 1/8 graphed. So what we'll do is we'll just put a point here just slightly above the axis. And what you can just tell me somewhere on your graph is that the order pairs that you graphed or what they were. So I'm graphing the vertex and I'm graphing this. Now, instead of plugging in -1 and doing the problem, remember that all of these parabolas are symmetrical. So I actually have an axis of symmetry that goes through the vertex. So I could actually draw my line of symmetry here, and then without having to plug in another value, see how this is 1 unit away? I could come over here 1 unit away and put it at -1 and +1/8. Because I need a left side of my parabola and a right side. So I can use the line of symmetry without having to plug in more numbers. So now I can make my graph. So here is my U shape. Again, I'm just trying to get a feel if it's super skinny or super wide. Now I need to come up with my focus point and my directrix line. And the way that I come up with that information is I use my p-value. Remember, the focus point is going to be 2 units away from the vertex. So I'm going to move it up 2 units. And my focus point is going to be right here. And my focus order pair is 0, 2. My directrix goes in the other direction. So it's going to be 2 units on this side. And it's going to be the equation y equals -2. The directrix line is always opposite of p when the order pair is 0, 0. When it's a U or an upside down U. If it's a C, it will be x equals opposite of p. So this is the information you need to give me. You need to be able to give me the directrix equation, the focus point, one other additional point in addition to the vertex. And then roughly sketch your U, your upside down U, your C, or your backwards C. Let's try another example. This time, it's a y-squared graph. Whenever it's a y-squared graph, this tells me the graph will either be looking like a C or a backwards C. And the way that I can determine which one it is this number. If this is negative, then my graph is the backwards C. If it's positive, it's normal C. Okay? Again, remember the general form is y squared equals 4px. Again, remember the number in front of the variable that's not squared is your 4p. So my 4p is negative 28. So I'm going to do 4p equals negative 28. This will allow me to solve to find the distance or the p-value. I'm going to divide, and my p-value is negative 7. I'm now going to graph my parabola. My vertex still is at 0, 0.
Micah Robinson, please report student services. Micah Robinson, report student services.
I need to find another point on my parabola. I can pick whatever value I want to plug in to get another ordered pair. So again, and you could plug in either x or y. So in this case, I'm going to plug in a y value, and I'm going to plug in 1 for y. So if I plug in y equals 1, I get 1 squared equals negative 28x. 1 squared is 1. Divide by negative 28. And x is equal to negative 1/28. So the order pair I'm going to graph is negative 1/28 and 1. Again, it's going to be hard to graph this. Again, this is why I want you to label the other order pair you're coming up with. Now, because this is going to be really microscopic like this, my graph is going to be super wide. You didn't have to plug in y equals 1. You could have plugged in x equals 1. But again, you're still going to get a really small number. Again, it doesn't matter what number you plug in. Try to plug in something that's going to produce the least amount of math. So when I go to graph this, I'm going to graph the order pair, negative 1/28 and positive 1. I'm going to come over here and put my point about there. And then I can also use the axis of symmetry, which is here, and I could put my other point over here. So I'm just trying to see that it's a really super wide graph. Again, you could just say that the point you graphed was negative 1/28, 1. Now I need to find the focus point and the directrix line. To find my focus point, I use my p-value. So again, the focus point is always inside that C or U shape. So I'm going to move 7 units from the vertex. So my vertex is at 0, 0. So I'm going to move 7 units, the p-value over. So I'm actually going to move over to negative 7, 0. This will give me my new focus point. So 2, 3, 4, 5, 6, 7. So right here is my focus point. My directrix is going to be opposite of P, so 7 units in the other direction. 1, 2, 3, 4, 5, 6, 7. And here is my directrix line. And again, it's an equation of the line. So you will tell me the directrix is x equals 7. And that's the information I need to see. So again, I need the directrix equation, the focus point, I need to know the vertex, and one additional point that you graphed. I think in the homework they may ask you to find the p-value, But again, you need that p-value to find the focus and the directrix. Let's try another one. Our vertex is still at 0, 0 on these. Now, notice again, remember the normal format that we want is either x squared equals 4py, or if it's the y squared, it's 4px. Notice this is the old format, if you remember. This is y equals 4x squared. I need to get x squared by itself because that's the only thing that should be on the left side. So I'm going to divide both sides by 4. And now x squared is equal to 1/4 y. The reason why I'm not going to leave it as y over 4 is I need a 4p value. And remember, the 4p is in front of the non-squared variable. So that's why I made it 1/4. So now I need to find the value of p. So I'm going to set 4p equal to 1/4. Now, you can either treat this as a proportion, add a 1 to the 4p, or just know that you're dividing both sides by 4, which is really multiplied by the reciprocal. I think it's easier if you put a 1 under the 4p and treat this as a cross multiply. So you would get 4p times 4 is 16p equals 1, 16, and then p equals 1/16. Or solve this however you need to. Multiply by the reciprocal, and you still get 1/16. Either way, however you want to solve for p. All right, so let's go ahead and get this parabola graphed. Again, my vertex is still at 0, 0. I need to come up with another point on my U shape. Again, it's an x squared graph, so this is a U shape because my 1/4 is positive. I'm going to plug in 1. So I could go back to my original, 4x squared equals y, or even the rearranged. It doesn't really matter. I'm going to plug in 1. So 1 squared equals 4 times 1 squared. So 1 squared is 1. 4 times 1 is 4. So the order pair I'm going to graph is 1, 4. So I'm going to come up here and put my point. Now again, remember you have this line of symmetry that goes through the vertex, the axis of symmetry. So we can use that line to get another point on the left side, or plug in -1. Either way, it's a lot easier to use the axis of symmetry. So this is my U shape. I now need to find the focus point and the directrix. Again, the focus point will be 1/16 away from the vertex. Again, it's kind of hard to graph 1/16, so you could just put it slightly above and say that that focus point is the order pair 1, 1/16, because you're taking the vertex and you're adding the p-value to the y because you're moving it up, and that's how you get that new focus point here. The directrix is opposite of p, so my directrix is going to be y equals the opposite of p, which is -1/16. So my directrix line will go here, and it's that equation. One more, and then we'll move on, and we're going to move the vertex. Next one, again, it's a y squared graph, so this is going to look like a C. However, remember the form we need it in is the y squared all by itself, and then equals the 4px. So I need to divide by 8 to isolate the y squared. And now I have 1/8 x. Remember, the number in front of the non-squared variable is your 4p. So again, you could solve this as a proportion. Do the cross products. 32p equals 1. Divide by 32. And your p-value is 1/32. Let's go ahead and get our parabola graphed. Then we can put in the focus and the directrix. So again, my vertex is still at 0, 0. I need to plug in another point to find another order pair to get the U shape here. But actually it's going to be a C. So I need to plug in another value. I'm going to use this equation. So y squared equals 1/8 x. I'm going to plug in 8 for x. So see when I put in 8 here for x, see how it's going to cancel that? Because 1/8 times 8 is going to give me 1. So y squared equals 1. And then when I square root it, it gives me plus and minus 1. So I could graph 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to plot 8 and 1 and 8 and -1. And notice it's symmetrical. I now need to find the focus point. Again, I'm using my vertex of 0, 0. My p-value is 1/32. So I'm going to add that to the x. And my focus point is now going to be 1/32, 0. So right there. My directrix on the other side, back side of the parabola. Again, it's opposite of p. So this is going to be x equals -1/32. That is another example of the vertex at 0, 0. Let's do a couple of examples where we move the vertex this time. We're going to bring back h and k from chapter 3. So if you recall from chapter 3, remember when your parabola was in this form, the h was the x of the vertex and the k is the y of the vertex. So in our parabolas now, we're going to see it in one of these two forms. The h is always with x, the k is always with y. So let's look at our first example. So here again, we're changing the vertex from 0, 0, and it's going to be some value that's in our equation. So again, I can pull my vertex out of this. Here is my h, here is my k. Remember, when you pull these out, because subtraction signs are part of the original formula, it's opposite of what you would think. So when it's a -3, what comes out is a +3, because that's what went in. And when it's a plus sign, what really went in, the equation was really negative, negative, and that's how it became positive. So my vertex is at 3, -2. I'm going to go ahead and plot that. And it's down here. Now, notice in your this form of the equation, the number outside of the parenthesis here is going to be your 4p. So you can see right here in this problem, my 4p equals 4. So I still need to find p. So 4p equals 4. Divide by 4. And p equals 1. So now when I go to find my focus and my directrix, it is going to be 1 unit away from that vertex of 3, -2. But let's go ahead and get our parabola graphed. Let's find an additional point in addition to the vertex. So again, my vertex is over here. So I would pick a number that's less than 3 or greater than 3 to plug in. Now this time, notice my vertex isn't on the y-axis. So probably the easiest point might be to find would be the y-intercept. So I could actually plug in x equals 0 to get the y-intercept. So I'm going to take my original equation, x minus 3 squared, y plus 2, and I'm going to replace x with a 0 and solve for y. And this will give me an additional point, which happens to also be my y-intercept. Again, you can pick whatever x value you want to plug in. So I'm going to divide by 4, and then 1/4 equals y. So my next order pair that I can graph is 0, 1/4, which is also my y-intercept. So I'm going to go ahead and plot that point. And again, we're going to approximate it. So it's right here. Again, I can use my line of symmetry to get the right side of my U. So notice this one is 1, 2, 3 away. I can come over here and go 1, 2, 3 away and 1 up. And now I'll have a nice balanced parabola. So I could come up. I've got my parabola graphed. And now I can find the focus point and the directrix. So again, we're using the vertex, and our vertex is going again to be 3, -2. Know that the focus point is 1 unit, because P equals 1, away from this, 1 unit up. So I'm going to alter my y, so I'm going to add 1 to the y, because I'm moving it up. So 3, -1 is my focus point. So right here. The directrix is 1 below the vertex. So if you took the y value of the vertex and you subtracted 1 from it, you get y equals -3. And that would be the equation for your directrix. So that is when the vertex is not at 0, 0. Again, the p-value tells you the distance away from the vertex. Let's try number 6. 2 more examples. Again, let's pull the vertex out. Oh, but first we got to get it in the right form. So again, remember the form should be x squared, x minus h squared equals 4p y minus k squared. I need to get this to be all by itself. So I need to divide both sides by -4. So x plus 3 squared equals, again, I'm going to write it so I have a 4p. So now my 4p value is right here. So 4p equals -1/4. Again, I'm going to put a 1 here and cross multiply. So I get 16p equals -1. Divide by 16. And p equals -1/16. So this is going to be the distance I'm going to move. Now let's also pull the vertex out. So the vertex, here's my h, here's my k. So my vertex is going to be at -3, +2. We could graph that. So put the point right here. Again, we need to come up with another ordered pair for our U shape. Again, plug in whatever number you want. Again, I'm going to find the y-intercept. So I'm going to set x equal to 0, and I'm going to plug that into the original. So here is my original. -4 times 0 plus 3 squared, y minus 2. -4 times 9, -36 equals y minus 2. Add the 2, -34. Wow. So this y-intercept is going to be way down. So again, I'm just going to label, and I'll say the y-intercept's way down here, and we'll say it's the order pair 0, -34. So again, I've got half of my U shape going on. Again, we've got a line of symmetry here. So we can get the other point. If this one's 3 units away on this side, I could go 3 over here and put the other point. And now I have the other half of my U. So this would actually be -6, -34. I now need to find the focus point and the directrix. So again, the focus, look at this. Okay, my focus point is going to be 1/16 away from my vertex. So again, remember your vertex is -3, 2. So my focus point's going to be just 1/16 away. And I'm going to subtract, actually I'm going to subtract that because it's negative from the 2. So I'm really doing 2 minus 1/16. Common denominator here. I can change this to 32/16. And I get 31/16. So my focus point is actually the order pair -3 and 31/16. If you want to make it a mixed number, you can. The directrix is going to be the opposite of P. So I'm going to actually add 2 plus or minus 1/16. So my directrix equation is going to be y equals 2 and 1/16. So just above this. And you can just label what it's supposed to be. If you made it improper, it would be 33/16. And it's y equals. One more example. Same thing. Pretty good? Next one. Again, it's a y squared. So, and the 24 is positive. So it's going to be a C. So again, my vertex, let's pull it out. Remember, this is K. This is H. So it's going to be 3, 2. Remember, the number in front of the non-squared term is your 4p. So I'm going to set it equal to 24. Divide. P equals 6. Now, let's go ahead and graph the parabola. Again, I'm going to graph the vertex. So 3, 2. And now I need to come up with another order pair. Again, I'll use the original. Pick whatever you want. You could either plug in an X or a Y. I'm going to find the x-intercept because obviously if it's a C, I'm not going to be touching the y-axis. So I'm going to set y equal to 0 and find the x-intercept. So I get 4 equals 24 x minus 3. Now at this point I can either distribute or I can divide both sides by 24. I'll just go ahead and distribute the 24. Either way, whatever you prefer. Your other option would be at this point, instead of distributing, divide both sides by 24, and then you would get 1/6 equals x minus 3 and solve that. Or do it this way, add the 72, 76 equals 24x, divide by 24. This doesn't go in evenly, but I can reduce it, and it becomes 19/6. Or 3 1/6. So my x-intercept is the order pair 3 1/6, 0. So I can go ahead and graph that. Again, we'll approximate it 1, 2, 3, and then we'll say 1/6 is about here. Again, remember you have your line of symmetry. So you could come up here and 2 away in this direction and say the point's about here. So again, really wide. And now I need to find the focus point. So the focus point, again, take the vertex. This time it's a C, so we're going to add the value of P. We're going to be adding it to the X value. So I get 9, 2 will be my focus point. 1, 2, 3, 4, 5, 6, 7, 8, 9, right here. And then the directrix goes in the opposite direction. So 3 minus 6, opposite of P, and I get -3. And again, it's an equation, so it'll be x equals. So here is my directrix. And again, this is 6 units away, and so is this. It's the p-value. So again, you should be coming up with the equation for the directrix, the focus point, the vertex, and then one additional point on your parabola. To find the other point, just use the line of symmetry. But you need to calculate the p-value in order to find your focus point and your directrix. So you have homework on this. It's not due till Friday. It is 19 through 30 all. Some of it is graphing it. Some of it is only finding the focus and the directrix. So just read the directions. Your homework tonight is the chapter review. You must complete it and turn it in. You do have all the answers. Just check them. And then whatever problems you don't understand, I will work out in class tomorrow. And if you're struggling tonight, shoot me an email. I can always work an example out for you and send it back to you. So test, the non-calculator part is Thursday, 9 questions. And then on Friday will be the calculator part. You'll only get about 15 minutes for the calculator question. So make sure you know how to use your calculator. So that is it.